This dome has been standing for nearly 2,000 years. No steel reinforcement, no modern technology, just Roman concrete. Meanwhile, bridges built 50 years ago are already crumbling. MIT scientists just discovered why Roman concrete is essentially immortal, and the answer was hiding in a half-finished living room in Pompeii, frozen in time since 79 AD. This is the verified breakdown. Concrete was the foundation of the Roman Empire. It enabled Rome's architectural revolution: buildings, bridges, aqueducts that are still operational today. The Pantheon's dome remains the largest unreinforced concrete dome ever built. At 43 meters in diameter, no one has successfully replicated this achievement in 2,000 years. Modern engineers use steel reinforcement, tension cables, support systems. The Romans used something else, something we're only now beginning to understand. In 79 AD, Mount Vesuvius erupted. But it didn't just destroy cities, it preserved them. MIT Associate Professor Admir Masic found something extraordinary. A construction site frozen mid. Workers had literally abandoned their tools. Piles of raw materials sat exactly where they left them. For the first time, scientists could see exactly what ingredients Romans used before the concrete was even mixed. Professor Masic described entering the site as emotional. Quote, "I expected to see Roman workers walking between the piles with their tools. It was so vivid, you felt transported in time." The archaeologists joked about him getting emotional over piles of dirt. But that dirt contained answers to questions scientists had been asking for centuries. The team analyzed samples using X-ray diffraction, Raman spectroscopy, and isotopic analysis. They examined premixed dry material piles, partially built walls, and finished structures. What they found contradicted everything written in ancient texts. Sand explained why Roman concrete has a superpower that modern concrete completely lacks. The Roman architect Vitruvius wrote the first known book on architectural theory. He described mixing lime with water, first a process called slaking before adding other ingredients. For centuries, historians assumed this was how all Roman concrete was made. But the Pompeii evidence tells a different story. The Romans weren't following Vitruvius's recipe. They were doing something far more dangerous. The secret is called hot mixing. Romans took quicklime highly reactive calcium oxide and mixed it with volcanic ash before adding water. This triggers an exothermic reaction. Extreme heat, the mixture essentially cooks itself. This creates something called lime-classed tiny white chunks trapped inside the concrete. For years, scientists thought these were evidence of sloppy mixing. They were wrong. These lime-clasts are the key to everything. Here's where it gets incredible. When cracks form in Roman concrete, water seeps in. That water reacts with the lime-clasts. The calcium dissolves, travels through the crack, and recrystallizes, literally filling the gap. The concrete heals itself. This process has been happening for 2,000 years. Every time Roman concrete cracks, it repairs the damage automatically. Modern concrete has no such ability. Our concrete uses Portland cement with steel reinforcement. Steel rusts. Rust expands. Expansion creates cracks. Water enters. More rust. More cracks. The cycle accelerates. Early 20th century engineers believed reinforced concrete would last 1,000 years. Reality, 50 to 100 years, sometimes less. Deterioration can begin in as little as 10 years. Consider the infrastructure crisis. The writer Robert Kurland estimates repair and rebuilding costs for concrete infrastructure in the United States alone will reach trillions of dollars. Bridges, highways, buildings all approaching their expiration dates. Meanwhile, The Pantheon dome weighs over 4,000 tons, has survived earthquakes, floods, and centuries of use and requires virtually no structural maintenance. The contrast is staggering. There's more. Roman harbor concrete doesn't just survive seawater, gets stronger. In 79 AD, Pliny the Elder wrote that concrete exposed to salt water becomes a single stone mass, impregnable to the waves and every day stronger. Scientists thought this was exaggeration. It wasn't. Seawater triggers the growth of rare minerals inside Roman marine concrete. University of Utah researchers found a mineral called aluminum tobermorite in Roman harbor concrete. This mineral is extremely difficult to produce in laboratories. It requires very high temperatures, yet somehow it forms naturally inside Roman concrete at room temperature over centuries. When asked how this is possible, researcher Marie Jackson said, "No one has produced tobermorite at 20 degrees Celsius. OX at the Romans." Professor Masic has started a company called DMAT to translate Roman concrete principles into modern materials. The goal isn't to copy Roman concrete exactly, we need different performance characteristics for modern construction, but the principles revealed can inform the design of next-generation, durable, low-carbon concretes. Concrete that regenerates itself. Concrete that lasts centuries, not decades. The ancient past may hold the key to a sustainable future. 2,000 years ago, Roman workers in Pompeii were renovating a house. They sorted tiles for recycling. They measured materials precisely. They followed techniques passed down through generations. Then Vesuvius erupted, and their worksite became a time capsule. 20 centuries later, their methods are teaching us how to build a more durable world. The builders in Pompeii created a legacy that would outlast their empire. Roman concrete is just one example of ancient engineering that surpasses modern understanding. The roads they built still carry traffic today. Their aqueducts still deliver water. Their architectural innovations shaped civilization itself. Next, we investigate the Via Appia, the road that connected an empire and why sections of it remain perfectly intact after 2 millennia. Thanks for watching, and be sure to subscribe.